Hello. So they want to use the Pythagorean Theorem Identities to show that cotangent, to find the cotangent of theta if we know the cosine of theta is 1 over 7 and the sine of theta is less than 0 or negative. So we're going to use the formula, the Pythagorean identity, 1 plus cotangent squared of theta equals cosecant squared of theta. So since we know that the cosine of theta is 1 over 7, that means the adjacent side is 1, the hypotenuse is 7. We need to find this opposite side, so we use the Pythagorean theorem, and we get a squared plus 1 squared equals 7 squared. We work that out, and it comes out a is plus or minus the square root of 48. Well, since sine has to be negative, we'll use the negative square root of 48 for the sine when we figure that out. So the sine of theta is negative square root of 48 over 7. In our equation, in our identity, we want to use the cosecant, so we take the reciprocal of the sine. So we get cosecant of theta is negative 7 over the square root of 48. So we plug that in for our cosecant, and we get 1 plus cotangent squared of theta equals negative 7 square root of 48 over 2. Well, when I square that negative 7 over square root of 48, I get 1 plus cotangent squared theta equals 49/48. I subtract 1 from both sides. I get cotangent squared equals 1 over 48. I have no idea why I wrote it down twice. Anyway, I'm going to take the square root of both sides. So I get the cotangent of theta equals plus or minus the square root of 1 over the square root of 1 over 48, which would be plus or minus 1 square root of 48. And since our cosine's positive and sine's negative, our cotangent of theta will be a negative 1 over the square root of 48. And if you go back and look at our triangle, cotangent is the adjacent over the opposite, so I'd have 1 over negative square root of 48 also. So that's how you do that one. You could have got it just by looking at the triangle, but we did it the long way.